Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our lessons on confidence intervals and sample size for proportion. In our last video, we treated quite a lot on confidence intervals for population mean, when our population standard deviation is known and when it is unknown. And then we learn how to calculate for the sample size too. So please, if you haven't watched that videos on that, kindly go back and watch it before you start your video on confidence intervals and sample size for proportion. Before we start the confidence intervals for sample size proportion, I want us to really understand the parameters in constructing the confidence intervals for proportion. One of the most common type of confidence intervals is one that uses proportion. Many statistical studies involve finding a proportion of the population that has a certain characteristics, and then you see this is our confidence interval for the population proportion. So this is it, but I want us to really understand the parameter that the p hat, the q hat, and our n, and for the z subscript alpha divided by 2 is something that you have already seen it in my previous video. So for this one, I'm not really going to waste much time on that. Yes, so when we are treating sorry, please, I'm coming. When we are treating the point estimate, right, I illustrated two diagrams, a big circle and a small circle, and I said that this big circle represents the population, right, and this small circle represents what? The sample. And within the population, it has three parameters, of which the population parameter, the population proportion is part, and then within the sample we have three statistics, of which the sample statistics is also a part. So here we having p hat and what our p, where the p hat is used to estimate what the population proportion, right? So when you come here, this is what our p hat, sorry, this is our population proportion. The p hat is what? The sample proportion. So here the sample proportion is equal to x divided by n, where our x is the number of sample units that possesses the characteristics of interest, and our n is the sample size. And so once we have our population proportion p hat, we can get our q hat, where our q hat is equal to 1 minus what? P hat, right? So this is an illustrated example for us to really understand what we have done above. So for example, in a study, 200 people were asked if they were satisfied with their job or professions. 162 said that they were. So the x, as you can see here, is 160. Those who really accepted that they were, they are really interested. And then we have these 200 people, which will be what? Our n. So here when you come here, our p hat will be what? X divided by n, where we have 162 divided by what? 200, of which I'm going to get 0.81. right? So once we have our p hat, we can get our q hat, where our q hat will be equal to 1 minus what? P hat, right? 1 minus p hat, of which we are going to get 0.192. So right now we'll be getting our p and our q, right? Of which once we have p, q, and our n, we can construct what? Our confidence interval. So this is the formula for constructing confidence interval. So here we are having sample. We are having what we call the sample. Please, I'm coming. Let me clean and write it well. Yes, thank you. So we have what we call the sample proportion minus the margin of error, and this part will be what? The population mean. This part will be the sample proportion, and then this part will be plus the margin of what? Error, right? So here we'll be having this one is what? Our population sample proportion, margin of error, and this one will be our population mean, sample proportion, and then our margin of what? Error. So this one to the left, we are just going to subtract the margin of error from the sample proportion. To the right, we are going to just add the the margin of error to what? The sample proportion. So where we have to just know that our MP, that's the sample size times the sample proportion, must be greater than or equal to 5, and our NQ must also be greater than or equal to 5. But you have to take note that in a question, if our population the sample proportion is not given to us, we will treat the sample proportion as 0.50, right? So let's go through examples for us to really appreciate what we have discussed so far. A sample of 500 nursing applications included 60 from men. From the 90% confidence interval of the true population, the true proportion of men were applied to the nursing program. So you have to just construct a confidence interval, 90 confidence interval, right? So from the question, we know that our N was given as what, 500, and our X is given as what, 60 men. So 60. So if you want our P will be equal to 60 divided by 500, of which we are going to get 0.12, and our K will be 1 minus 0.12, which is 0.88. Right now we have our P, we have our Q, and we have our N to be what? 500. So once we have these three parameters, the work is done. And then we just learned at the top there how to construct the confidence interval. We have our sample proportion minus the margin of error. That is d subscript alpha divided by 2 square root of P hat times Q hat divided by N less than P hat plus z subscript alpha divided by 2 square root of P hat times Q hat divided by N. So this is our formula. So once we have our N, we have our P hat, we have our Q hat, what we have to do is to just substitute them into the formula. But you could see that we have z subscript alpha divided by 2. The z subscript alpha divided by 2, I have taught you how one can find z subscript alpha divided by 2 using the normal distribution table. We know that here our confidence interval was given as what? 90%. And then our alpha here will be given 1 minus our c, that's the confidence interval, which will be given as 0.1. So once you have 0.1, it will be z subscript 0.1 divided by 2. Divided by 2. Oh, please, I'm coming. Divided by 2, of which you are going to get z subscript 0.05. We just subtract 1 from this one. We subtract this one from 1 to get z subscript 0.95. So we just go straight to the z table and locate the probability of 0.95. Trace it to the top, trace it to the top and down to get our z score for z subscript alpha divided by 2. So if you haven't watched the videos on that, once you watch the video, it will teach you how you can get the z score having these probabilities, right? So once you trace it from the table, we are going to get 1.65. 1.65. So this 1.65 will really help us to construct our confidence intervals, right? So here we'll be having 0.12 minus 1.65 times square root of 0.212 times 0.88 divided by 500, right? We know that our P was given as 0. That, right? And then we know that our z subscript alpha divided by 2 was given as 1.65, and we know that our P hat was given as 0.1212, and our Q hat was given as 0.88 divided by our N, which is 500, right? So we do the same, but when you go to the right side, you are just going to add instead of subtracting. You are just going to add, and what of it when you do, you get 0.12, and the whole of this one will give us 0.024, and then here too will be 0.12. The whole of this one will be 0.24. You are just going to subtract here and then just add here. Once you subtract, you are going to get 0.096, and when you add, you are going to get 0.144. So hence our population proportion lies our population proportion lies between 0.096 and 0.144. So hence you can be 95 confident that the percentage of applicants who are men is between 9.6 and 14.4%. So let's go through another example. So this is our last example under this section. It says a survey of 1,721 people found that 15.9% of individual purchase religious books at a Christian bookstore. Find 95 confidence interval for the true proportion of people who purchase their religious book at the Christian store, right? So here, as we did in our previous video, our N here will be giving us 1,721 as our N. But note, we know that our P hat is giving us our X divided by N. But in this question, our x was not given to us, but only our n was given to us, right? But you could see that he has already given us our p hat inside the question, that he said a survey of 1,721 people found that 15.9% of individual purchase religious book. So he has given us the percentage already, right? So our p hat here is 15.9%, and we know that let me write it here so that you can see. And we know that 15.9% can be written as 15.9 divided by 100. And once you divide this by 100, we are going to get 0.159. So here when you come, our p will be given as 0.159, and our q, as you can see here, you subtract 0.159 from 1, you're going to get 0.841. So here we have our p hat and we have our q hat, as you can see here. So p hat and q hat, we are having 0.159 and then 0.84 for the p and the q hat, and then we have our n to be 1721 as our n. So we just go and just substitute it into our formula, right? And then we know that our formula is giving us, let me write it again so that everything will be very simple here. We know that our formula is p hat minus z subscript alpha divided by 2 square root of p hat q hat divided by n less than p hat plus z subscript alpha divided by square root of p hat times q hat divided by n. So this is our formula. Once you have our p, q, and n, we just substitute inside, right? Know that our p was giving us 0.15 now, and when you calculate for z subscript alpha divided by 2, so here our confidence interval was given as 0.95. So our z will be our alpha will be given as 1 minus 0.95, of which our alpha will be given as 0.05. So here you'll be getting z 0.05 divided by 2, of which you get z sub 0.025. Subtract this, you subtract the whole of this from 1, I'm going to get z subscript 0.975. We go straight to the z table and get our z score, right? Of which I've already done videos on that. So please, if you haven't watched the videos on that, kindly go back and then watch it. Once you calculate that one, we are going to get our z subscript alpha divided by 2. So we are going to get our z subscript 0.975 to be 1.96, right? We are going to get 1.96, and then we just substitute our p hat and the q hat divided by our n to get the whole this expression. When we go to the right hand side, the same thing, but just like you are going to change the addition, right? Sorry, the subtraction to addition to get this one. Once you do the correct subtraction and addition, you are going to get 0.142 and a 0.176, right? So here, hence, you can say with 95% confidence that the true percentage is between 142 and then 17.61%. So this is the end of confidence interval for proportion. In our next video, I'm going to learn how to calculate for the sample size of the proportion. So kindly stay tuned. If you are new to this channel, please kindly subscribe, like and share so that this video will go viral. Thank you for watching. Bye.